Greetings from VNR VJEC. I am K. Anitha, Assistant Professor in the Department of CSE, AIML and IoT. Today I am going to give you a lecture on overview of the course and WIT and WIL of the image processing and computer vision. This is the final year first semester subject in BTech curriculum. Before going to the session, I would like to explain the need of the course, why we learn this course. The image processing and computer vision has widespread applications across the industry, research and academia. It plays the vital role which enables the machine to understand and interpret the visual information. This enhances the critical and algorithmic thinking innovatively and problem-solving approaches, which are the foundations of artificial intelligence and machine learning framework, which will be useful in very real-world applications. Next, for example, if we know about the X-rays, CT scans, MRIs, angiograms in medical field, and land detection, recognition of obstacles, track the pedestrians for autonomous vehicles driving, traffic control, number plate detection in transportation system. Daily we are using the biometric face recognition in smartphones, in security and surveillance. And next, biometrics. Next, monitoring the crops, find the diseased crops in agriculture field. Next, Google Maps and weather reports by using the satellite images, quality control in industries. Likewise, many applications has these type of image classification, extracting the knowledgeable information from several domains. Next, coming to the topic of image. What is an image? An image is an array or a matrix of pixels arranged in the form of columns and rows. And also we say that an image is a projection of 3D scene in 2D plane. Next, coming to the point of image, how we capture the image, 3D scene into 2D plane. This is one explanation. Here we have the image sensor like an eye or a camera. The structure of this dimensional is defined as this is the 3-dimensional. Here we have 6 planes, top, bottom, left and right, and near and far. Here the object which was nearest to the eye is showed as bigger one, and the object which is far from the eye, it will be shown as smallest object. This is the best example for projection of 3D plane. It is displayed on 2D plane. Next, types of image. When coming to the types of image, we have 4 types of images. First one is RGB, red, green and blue. This is indicated by using 3 arrays. The combination of RGB formed other colors. These are ranges from 0 to 255 of grayscale 8 bits. Next, the first image indicates that this is the RGB image. And next one is indexed image. It is defined by using only one index, just like the index in our textbook. Next, one index number which holds RGB levels. Here in this picture, see, this is the index table and this one is the lookup table. The elements in the matrix are not the real elements of the colors because these represents only the intentionally these points only. Next, the lookup table have the original colors which are having in this color palette. Next, grayscale. Next type is grayscale. Here it is also followed only one array. Likewise, X-rays, CT scans, MRIs, angiograms, these are all having these type of grayscale images. These are also ranges from 0 to 255. And last one is black and white image. Binary or monochrome, also called it as black and white pictures. The last one is black and white images. Binary or monochrome image also we called it. Next, it contains 2 pixels. 0 indicates black and white indicates the 1 to 255 numbers. Next, when coming to the point of digital image, the digital image is a representation of two-dimensional image as a finite set of digital values called picture elements or pixels. Each and every pixel here, it defines the intensity or brightness of the color. Here, the example of the formation of scene element or real-time object as image into digital image. Here, the illumination energy source, it may be sunlight, infrared, X-rays, etc. When it comes onto the scene element, means real world object, it will projected into the imaging system. The imaging system may be a camera or sensor or any eye or any type of image acquisition. Next, it will be projected on the image plane and it converts into grid form, means rows and columns. Next, it will be converted into digital form. So these are the pixels. These indicates the pixels. Next, the digital image is the representation of 2D array. Here we have f of xy equal to m cross n array elements. M defines the number of rows and n defines the number of columns. Here x and y are called as coordinates and f is called as intensity or gray level of the image at that particular pixel. Next, image processing. In each and every image processing system, each image will be treated as the 2D signal when applying contains predetermined signal processing methods. Image processing focuses on two major concepts. First one is improvement of the image for human interpretation and next one is processing of image data for storage, transformations and representation. Next, we all know about the Jungle Book. This is the animated picture of the story Jungle Book. One picture can worth more than 1,000 words. Here we have 5 types of roles and they have their own features and knowledgeful expressions. The image processing is used to extract the knowledgeful information, color concentration, compression the files, restoration of the files, all these types of operations are there. Next, image processing. In image processing, we have 3 type of steps. First one is importing. Importing the images via image acquisition tools. And next, analyzing and manipulating the whatever the images acquisition, whatever the images we acquire from acquisition tool. Last one is output. It is the resulting image or report of some type of attributes from the image analysis which we got. Image processing and computer vision has 2 subjects. First one is image processing and second one is computer vision. Image processing is the manipulation of digital images using computer algorithms to enhance, analyze or extract information from them. Next, whatever the computer vision is a technology that machines use to automatically recognize images and describe them accurately and efficiently. Here we have the images which are acquired from the image acquisition tools like sensors, cameras, eyes, likewise. And next here at the computer vision, the machine has captured the images or videos which we have to describe them according to the features or some of the efficient algorithms. Next, here in image processing, input is image and output is also image. Whereas in computer vision, the input is image and the output will be in the form of records or attribute values or maybe image. And next, some set of operations which we are using in image processing are smoothing, sharpening, compression, contrast, watermarking, brightness, edges and region. And some sort of operations which we are used in computer vision are position, action, identification, measures, labels, and projection. These are the basic steps of image processing systems, which we have a problem from the problem domain. Next, it will be imported from the image acquisition tools, and next it will be image filtered options and enhances, and next the operation will be done on image restoration, some of the color image processings, and next wavelets and other image transforms, compression and watermarking, and morphological processings, segmentation. Here segmentation means dividing the image into different objects. Next, feature extraction, extract the knowledgeful information from the images, and last one is image pattern classification. After that, we get the output of the images or knowledgeful information in the form of object or attribute values. Next, when coming to the point of applications of image processing and computer vision are, first we have to, already we have explained, these space image applications, remote sensing via satellites and other spacecrafts are very useful in real-time world scenarios. Next, images acquired by satellites are useful tracking of Earth resources, geographical mappings. Next, when we say that medical applications like processing of chest x-rays, MRI scans, angiograms, ultrasonic scannings, etc. Next, robotics and automated inspection of industrial parts. Next, communication over computer networks, many social networks also there. Next, image transmission and storage for business applications. Radar, radio detection and ranging to detect, locate and track objects. Next, sonar, sound navigation and ranging, uses sound propagation, usually under the water it will be happen, to navigate, communicate or detect objects. In agriculture field, for identification of crop diseases, crop monitoring and etc. These are the main applications of image processing. So coming to the point of prerequisites. Next, coming to the point of prerequisites, here we have to learn before going to the learning image processing systems. First one is signals and systems, digital signal processing, and next last one is basic mathematical features like linear algebra, calculus, probability and statistics. Next, what are the course objectives? First one is, first and most, understand the digital image fundamentals including sampling, quantization and color imaging. Next, apply enhancement and morphological techniques in spatial and frequency domains. Analyze the image restoration, compression and segmentation techniques. Next, explore edge, blob, line and corner detection algorithms for computer vision tasks, which are main fundamentals of AI and ML frameworks. Next, implement the feature detection, matching of images and applications like image stitching. Next, course outcomes. These are the 5 course outcomes. First one is, understand the general terminology of digital image processing. Imagine the image enhancement techniques in spatial and frequency domains. Evaluate the methodologies what we have applied for image segmentation and restoration. Apply edge, line, corner detection techniques to extract meaningful features from images. And last one is, implement the interest point detection, feature description and matching methods for image analysis and stitching. Next, the concept is WIT and WIL. WIT and WIL is the very effective and most important teaching and learning, one of the methodology in VNR VJIT which we are following. Next, what is meant by WIT? What I am teaching, why I am teaching. When coming to the WIL, what I am learning, why am I learning. Here we focused 5 units which are in our syllabus. Unit 1, fundamentals of image processing and image transformations. Next, unit 2, image enhancement, frequency domain methods and morphological image processing. And in third unit, we have image restoration, image compression, and image segmentation. These 3 units cover the image processing concepts. And next, fourth unit, introduction to computer vision and applications. In fifth unit, we cover the interest point detection, feature descriptors, and matching, which are covered in computer vision tasks. So, these 5 units are covered in the real-time application. First of all, image acquisition. It will be completely quality criteria defined. Whatever the images extracted from the acquisition tool will have to follow the criteria definitions. Next, when coming to the point of this point, here further the processing, the image must be pre-processed, like removing the noise, restoration, enhancement, color complexions. Like these type of modeling techniques are applied on images. And next, it goes through the segmentation. Whatever the defected images or whatever the defected colors and parts, these are removed from the images. Next, after completing the segmentation, it will come to the point of feature extraction and selection. Here, the features which we have to extract are color, what is the texture, what are the movements, what is the mean value, and how much it have to rotate, scaling, transformation, and these types all comes under the feature selection. Next, coming to the point of compare criteria, judge, and recognition. This is the process under the computer vision. A machine has to recognize these types of images which are pre-processed, which are completed their pre-processed, will come to the computer vision under the machine recognition. After this, it has to give some labeling, some type of knowledge base models to form the knowledgeful images or data, which we get the output in the form of. Next, here we have the contents in Unit 1 in Fundamentals of Image Processing. Basic steps of image processing system, sampling and quantization of an image, the relationship between pixels, imaging geometry and color imaging. This is the first part in Unit 1. Here we have one example, image acquisition. And next, image enhancement. Here we are using adjustment of brightness, sharpness, details, etc. And next, image restoration. Reduce the motion blur and improve the camera focusing. And next, color image processing. It has grayscale and contrast. And next, multi-resolution processing. How and high frequency for blurrification and add text here. Next, compression of the images using JPEG 2000 techniques. And next, add text here. Here, each and every field has the text adding option. Next, morphological processing. And next, segmentation. Identify the related or the undefined objects. And next, representation and description of extract features for future analysis like edges, textures, and shapes. Recognition and interpretation is the last model. Here, recognition of land type, vegetation, coverage, urban city, and likewise these operations, these set of operations are under the recognition and interpretation. Next, coming to the second part of the Unit 1, here we have discrete Fourier theorems and Hare theorems for transformations. Next, Unit 2 cover 3 concepts. First one is image enhancement. Here, image enhancement, spatial domain methods are there. Histogram processing, fundamentals of spatial filtering, smoothing spatial filters. Like all these types of filters are applied on images for enhancement of the images. Here we have the input type of one message, and after applying the filtrations, we get these type of output. And next, second part is frequency domain methods. Basics of filtering in frequency domain, image smoothing, image sharpening, selective filtering, like all these types of operations are applied here. And last one is morphological image processing. Here, dilation, erosion, opening and closing, hit or miss transformations, and some of the basic morphological algorithms are applied on images. Next, in third unit, here also we cover three concepts: image restoration, image compression, and image segmentation. In image restoration, algebraic approaches are applied here. Without loss of the information, the image will be restored. And next, image compression. Here we are applying the compression fundamentals and different types of compression models. Here in this example, 100% size of the image will be compressed in 53%. Next, here it is the segmentation. Image segmentation concepts, thresholding, region-based segmentation. These are all the concepts covered here. And next, in unit 4, computer vision concepts are here we introduce, like different applications: image classification, object detection, image segmentation, 3D vision, facial recognition, edge detection, pattern detection, and object tracking. These are all the different applications in computer vision. Next, here we have to apply Gaussian smoothing and Gaussian computation methods on images. Next, this is the last unit. We have interest point detection. This is the introduction topic. And next, feature descriptors and matching. Here we have different types of techniques and models which we applied for matching the images, whether these are equal or not. Here we applied histogram of oriented gradients, local binary patterns, and scale invariant features, transform, etc. And next, coming to the point of reference textbooks, these are all the topics. In first unit, the 3 units are covered, and next 4th and 5th units are covered in this computer vision textbook. And next, these are the more reference books for this image processing and computer vision course. Next, these are the YouTube reference videos which are going concept-wise image processing techniques. And next, these are the reference videos from NPTEL. Okay, thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.